If you're planning on traveling, why not pack up your bags and explore space?
It's way better than all the regular haunts we have here on Earth. There's just one very small catch: no gravity.
This causes more problems than just being unwieldy.
Weird health issues like extra bone growth, lower muscle mass, and more can occur. Fortunately, artificial gravity can solve those problems. A force is anything that causes an object to accelerate or change velocity. Acceleration and velocity are both vector quantities with direction and magnitude. If no net force acts on an object, it has inertia, meaning that its velocity stays constant. That leads us to the concept of a normal force, which is the perpendicular force a surface enacts upon an object to counteract other forces like gravity. It is what prevents a book from falling through a table, and why you can't walk through a wall.
At which you can walk through walls? At a quantum level.
Finally, reference frames. For our purposes, these can be thought of as how an object, like an astronaut, and its surroundings, like a ship, are moving. When one or both frames accelerate, they are known as inertial reference frames.
There are two main ways to cause artificial gravity: linear acceleration and centripetal acceleration. This type is pretty straightforward. Get it?
Say the ship begins to accelerate forwards. Due to inertia, the astronaut would still be going at the same speed, and would appear to move backwards through the ship. At that point, they would hit the wall, and it would exert a normal force on the astronaut, giving them the sensation of weight.
Because after all, the feeling of weight comes from the normal force.
Elevators actually do this all the time. When an elevator doesn't accelerate, the person would feel normal weight. When the elevator accelerates up, a greater normal force is required to accelerate the person and they would feel heavier, though they haven't gained mass. The opposite is true for accelerating down. You can experience this at home with a rolling chair. The centripetal force can also simulate gravity. It is any force that always points towards the center of a curve. Take the Earth and the Moon. Although due to inertia the Moon would like to escape, Earth's gravity always accelerates the Moon in towards itself. The combination of both results in a sort of circular orbit about the Earth. So gravity is the centripetal force in this case. A rotating spaceship does something similar. If the astronaut has velocity relative to the spaceship, they'd move towards the outside of the ship. At that point, a wall would provide the normal force, which would be the centripetal force, thus simulating gravity.
Those big spinning amusement park rides and centrifuges do pretty much the exact same thing.
Now, to the astronaut, it would seem that some force is pushing them towards the ground or wall. This is referred to as the centrifugal force. It's just a result of inertia and justifies calculations inside the ship.
Oh yeah, speaking of things that don't exist, no spacecraft capable of sustained artificial gravity has been made yet. So I guess traveling on Earth is the better option, for now.